From planning to reality. The virtual commissioning of hydrogen plants. This episode highlights the virtual commissioning of hydrogen plants and how companies can save time and costs by planning them digitally from the start. Siemens offers tools and templates to simulate the entire commissioning process and to build a digital twin from the very beginning, which is then maintained during the operation of the plant.
Get ready for Hydrogen, a Siemens podcast with Michael Pretorius and Philip Glaser.
And the person who deals with this all day is Philip Glaser, who does almost nothing else but click back and forth in his dashboard and can explain exactly how it works. So already in the process, before the plant is physically built in front of me. Philip, what do I start with? How do I begin?
So, you should ideally start very early, namely when you have to make your investment decision and already begin with the basic concept of your plant. Because at a certain point in time, you have the situation where you need to make a decision where you want to build your plant. At some point, you need to determine what capacity this plant should have. You need to somehow assess whether you have the appropriate logistics around it, whether you expect to purchase enough affordable electricity, how the availability of renewable energy looks like there, and also, for example, how much water you need at that location. And indeed, already in this area, in this situation, you can start working with our simulation software GPROMs. We have prepared an incredibly simple library for hydrogen, where you can easily access the different components that are part of such a hydrogen plant. Everything is prepared and then you simply get some data around it. You can already play around with what capacity do I want to have? What would that mean? How much water do I need for that? And similar things. And with that, I can also start my conversations, for example, with investors in a completely different way and argue and show that I already have a well thought out concept.
Let me give an example. I am now the owner of an industrial park on the outskirts of a large city, a little further out. And I know in this industrial park there are different companies, some of which need a very, very large amount of electricity with high energy, while others need less. I might now also have a solar park around the corner, let's say a field with some solar panels on it. I can also purchase wind energy, and of course, I can also source electricity from the local grid. And here I might have space, let's say, for 10 or 12 construction containers that are large enough to fit an electrolyzer. This would be a scenario where I could say, I will get an investor now, because it would make sense to possibly store electricity with hydrogen at such an industrial park, so that I can always produce green.
Yes, absolutely, exactly. So that would be a nice example. And of course, also the question of what capacities do I need at that point? Where is my customer? What would my customer need, for example, in terms of hydrogen? And then it would be possible to calculate back how much electricity I need for it, where I can get the electricity from, whether I have the possibility to obtain green electricity, with whom I need to make a contract, but also the question of how much water I need and where I can get the water from. Perhaps there is also an industrial facility at the location where we might be able to source water, as we have customers who use water from an industrial facility or something similar. A nice example of how you can think it through thoroughly and integrate it into an overall concept, starting with such a simple simulation.
Now you're saying I need to figure out how much hydrogen I actually need. I assume that you don't need any hydrogen at all, and that I actually need electricity, and I just want to use hydrogen as an energy storage so that I have electricity when I can't get any from other energy sources. Does this make sense?
Of course, that you convert it back into electricity as well. Yes, that makes sense too. I was assuming, for example, if you are talking about the chemical park, we naturally have the issue that hydrogen is used as an energy carrier, but it will also be an important raw material for the future for the chemical industry. But of course, the case that it is an intermediate storage is quite naturally also absolutely one of the many scenarios as well. So this is a very broad field, which is a lot of fun. These business models and the different things that are currently emerging around hydrogen, which are also being explored. And precisely for this reason, it makes sense to work with simulations to thoroughly think things through in advance. I also need to build a business model around it. I need to build a business case around it when I am at that point. And for that, I need to be able to comprehend, understand, and test things. And even there, working with simulations with virtual things is absolutely enriching and easy to do because it is very carefully prepared accordingly, and you don't need a bunch of people who can simulate very complex mathematical models. Instead, it is prepared to the extent that with just a few clicks, you can gain some transparency and easily play through different cases and scenarios.
I'll stay with these examples for a moment so I can have a tangible image in front of me, because you just mentioned the chemical park. It could also be a park where, for example, cement is produced, a concrete factory, a glass works, all sorts of things, but of course also large industrial plants, or let's say large shopping centers, large industrial parks. Maybe there are other companies in there that simply need a lot of electricity because they produce something there. These are different business models or different motivations for working on site with hydrogen as an alternative energy carrier, simply to be able to produce in a green and sustainable way. That was the initial situation. And now I want to simulate the whole thing. I gathered that I need to consider where to get my water from and how much water. Where do I get my electricity from? Do I get it from wind? Do I get it from solar? From other sources? When do I get the electricity? How green is it? And how much space do I have on the plant to ultimately place the electrolyzers? What are the pathways like? And what do I do with the hydrogen? Where should it go? Is it immediately converted to electricity? Is it somehow stored in some silos or tanks? Those are the considerations I hear. With which tool or toolset do I plan something like this?
As previously mentioned, the simulations at this early stage would be done with GPROMs. However, I also want to mention when we talk about this that we naturally also offer corresponding consulting services around it. Our Siemens Advanta, our in-house consulting service, has already successfully advised numerous clients and various regions and even entire clusters on how to effectively and efficiently set up a local hydrogen ecosystem and how the elements interact seamlessly. And of course, in process engineering consulting, we can say, okay, we can also provide some support in the initial feed phase, in the initial basic design of the plant. So, we have a relatively extensive, comprehensive, and diverse offering that is truly interdisciplinary, ranging from strategic, business-oriented topics to process engineering. But still, your question was, how does it actually continue from there? That means, in principle, we then proceed to somehow establish the configuration of the project. So when I have this basic concept, the question is, how do we actually proceed with the implementation? For this, one often looks for a plant constructor, such as an EPC, to build the entire plant. It must also be determined which electrolysis technology to use, which electrolyzer manufacturer to choose, how many electrolyzers to include, and the other plant components. Hydrogen plants are largely driven by the fact that they are composed of different package units, meaning different plant components, which are then integrated. This means the plant builder plays a very, very important role. It is indeed important that now, in this conglomerate of different players, namely plant manufacturers and suppliers of package units, the most important one is in there. The most significant among them is, of course, the manufacturer of the electrolyzer, the plant operator and owner-operator, and the various suppliers. They are naturally involved in such an overall construct in some way. And now the crucial point is essentially to say, now I have to determine which toolset we will work with. And there we would indeed actually recommend to everyone at that point you are in a very crucial point, because this is where it is decided whether I really get into this digitalization or not. If all players were to use different tools, such as, and perhaps even use various tools for different tasks, I would end up with the situation where a lot of data is stored in different tools. Our approach is definitely different. We want to advocate for it to be in one tool. For that, we have Comos. Comos is our central tool where everyone involved in plant construction and engineering works, possibly also using open interfaces when other tools are used selectively, so that Comos can ultimately build an object-oriented data model of the entire plant through the normal engineering process. This is what we call integrated engineering, which also means that, for example, different disciplines can work in parallel and do not have to work sequentially. That means I am a little bit more rapid, and as the icing on the cake, as an additional benefit, we have also created the previously discussed templates, libraries, and blueprints for hydrogen in Comos. This means we also want to make it as easy as possible for the plant builder, the EPC, to use these tools, to use Comos, because you don't have to start from scratch with the engineering, but have a basis that can then be adapted to the individual situation. Of course, it never fits perfectly. Every plant is individual, but at least Hydrogen plants are more similar to each other than any two random chemical plants, and that's why we have prepared it to make it as easy as possible for the plant builder.
I try to imagine it a bit like when I'm building a house and I have a planning software where the architect, the carpenter, the roofer, the person who builds the kitchen, and the one who installs the range hood and the heating all work in the same tool. So I don't have to plan everything anew each time. Almost even before the house is built, you know what the energy efficiency of the house will be and how much electricity I need when the range hood is running.
Excellent example. I absolutely think everyone who has ever built a house would like to have this now, right?
This means, conversely or in transparency, in the other example, the person who is the owner-operator of the plant plans in GPROMs with the one who supplies the electrolyzer, plans the plant with the one who builds the plant components around it, also plans the plant with the one who will operate it later, or to whom it belongs. Owner-operator is the operator, sorry. But you know what I mean. These different operators, trades play a combining role.
Let's think this through briefly. This is a nice example. Let's think this through briefly. I think this is a beautiful example. We'll sort this out together exactly. The owner-operator in this example would be, so to speak, you as the home builder, essentially as the owner of the house, the client, essentially the developer, right? So you would be the developer, and now you say, well, of course, I don't want to personally commission all the trades myself, but rather I am looking for someone who can do that. That means you go to a developer and say, I am making a turnkey agreement with the developer, a lump sum contract, a fixed price contract, please build this house for me. And now, of course, the same thing happens as with the developer. The developer, on one hand, may naturally have some tools in use and has their construction description, their standard construction description. But as a builder, you might indeed also have certain wishes because this house is something you want to live in for the next 30 to 40 years. Incidentally, quite similar to how as we in fact presume the hydrogen plants will be operated, that means you will in some way have a negotiation between what you want as a developer and what the developer has in their standards. And now comes a very important and crucial point. If, as house builder, you want to have a digital representation or twin of your house because you understand that this digital twin significantly helps you, for example, to save energy in your house, optimize and improve your house's overall performance, and simplify your house's routine maintenance tasks and effectiveness, and you know how very significant this impact is on your costs or your performance, then it would be extremely important, for example, to say, dear contractor, please build it in such a way that I ultimately end up with a comprehensive and detailed digital twin of my facility.
So it would mean that, in this builder-developer example, I would also be able to see later in the digital twin when I need to renew the staircase because the wood is rotten.
That's a nice example, exactly. For instance, this. That means you would want to tell the developer, look, it's not only important to me that the house stands in the end, but it's also important to me that I have this digital twin of the house in the end, because that's crucial for my costs over the next 30 years.
To go back to the example of the hydrogen plant, does that mean in this GPROM software you just described, you plan all the technical components?
In Comos, exactly, in Comos. In this case, GPROMs is the simulation. And in Comos, we plan the plant so that at the end of the process, we have all the plant data in Comos. We have all the simulation data in GPROMs in the simulation, and the third component is automation, where my live data, my as-is data from the plant comes from the processes.
But everyone who is essentially involved with the plant, in construction, operation and planning, works with these three tools.
Exactly, that's the idea. To have an object-oriented data model ultimately, at the very end, in Comos, which also supports me in operations, for example, in the areas of maintenance, performance optimization, and similar things.
This means that before the plant is built, I can ultimately already start procuring the materials and the components I need to purchase. But theoretically, I can also have virtually built the plant and already train the personnel.
Absolutely. I just want to briefly address a point before we do this. About this win-win situation. Yes, you have the situation. Now let's look at the hydrogen topic. The owner and operator of the plant, the investor, says, I want to have this digital twin in the end. Yes, and on the other side, he has to discuss with his plant builder, I would like you to use Comos for this. Now, of course, you can have the situation where the plant builder is already using COMOS, then it's a very simple matter. It can also be that the plant builder does not use COMOS after all. And now we have exactly the situation where we have tried to create a win-win situation for both, because the plant engineer, of course, has the advantage that if he uses COMOS in his engineering, he doesn't have to start from scratch because he can use our predefined templates. And secondly, the plant builder will certainly be in a situation where they do not want to build such a plant just once, but rather 2, 3, or 4 times. Like a property developer, the plant builder also thrives on this. He also makes a living by repeatedly building, I would say, similar row houses, prefabricated houses, or whatever. And so it is here as well. This means we have created a win-win situation for the plant builder and the plant operator. The plant builder significantly saves engineering costs and reduces risk in engineering. Because he can use pre-made templates, it has the advantage of being able to build the plant repeatedly in a similar form, reusing the engineering. The owner-operator, the plant operator, investor, owner has the advantage of having this digital twin at the end, which can be used in operation for performance optimization, maintenance activities, remote operation, and similar tasks.
So, it's like a child's room with blocks, many small blocks in various colors, or 3 blocks, 4 blocks, or 2 blocks. And you basically not only have the construction manual, which building blocks can be assembled in what way to create a house or a small train, but you also have these things planned in such a way that the person who wants it later can see what the outcome will be, how long it will take, and can theoretically scale it right away.
Absolutely.
We were now at the beginning of the process where I am considering where this plant will be located, where my resources will come from, and what my needs are in the simulation. We just had 2 tools that I can use to plan and simulate this. At some point, the plant will become operational, which means I will also need personnel to operate this plant. What about training, maintenance, and the entire virtualization of safety measures later on?
Exactly. So if we, for example, have used COMOS or we use COMOS for plant engineering, then we can bring this data from COMOS directly into the control technology, so that in control technology engineering, in process control technology, you have to map the automation logic in some way. What happens when all the interconnections, control related things, and so on, incorporate functional safety, safety systems, and so on. And I don't have to start from scratch. I can directly import the plant as it exists in COMOS into the control technology. Once my control system is indeed in place, some control system engineering is naturally necessary. Of course, we can't completely avoid this because in plant planning, not all the connections for automation are certainly available. When that is in place, SIMIT comes into play. This means that with the implementation of SIMIT, we gain the capability to effectively and efficiently carry out a comprehensive simulation of the entire automation process. This in turn has 2 use cases. One is that I can use it to perform a virtual commissioning, such as commissioning is the most critical point in the entire plant construction, because if I overlook errors and problems that only become apparent during commissioning, they usually cost me a lot of time and very, very much money as a rule. And the second major use case, which you just alluded to, is the topic of operator training. I can, as a result, train my operators on the plant at that time, allowing them to become familiar with it. This is undoubtedly an extremely crucial point, especially when new plants are being built or when remote plants are to be operated remotely. A very important and significant point. And it goes as far as allowing, of course, now thinking briefly about the connection to COMOS, I can indeed also let the maintenance personnel practice already, and they can familiarize themselves with the plant and already check whether we can access everything, or if we need a ladder or a lift somewhere, or if all parts of the plant are accessible, and how we can actually plan various maintenance processes. It is indeed really quite a challenge nowadays to find enough experienced maintenance personnel. This means that well-planned maintenance and servicing processes are an important topic, and I can already do that before the plant is actually up and running. Even though not a single groundbreaking has taken place and nothing has been built anywhere in any way.
And this automation, what a digital control room looks like, how it all comes together, that's such an exciting area that would suggest, Philip, for us to look at in a separate episode. So it's worth subscribing to this podcast and staying tuned, because in the next episode we will talk about the digital control room.
This podcast was done by humans but localized with the help of AI. Thanks for listening.